Welcome back. Let us continue with the 7th question from EdXL, International Advanced Level, January 2021 PP paper. This question is from the integration chapter. So let us see what it asks. Solar panels are installed on the roof of a building. The power peak produced on a particular day in kilowatts can be modeled by the equation. This is the given equation for us to refer, where the time is in hours after midnight. The range for the time in hours is given between 8.5 to 15.2, including 8.5 and 15.2, because you can see the less than equal to sign is given here. The graph of P against T, that means the graph of power against time, is as shown in figure 1. A table of values of P and P is shown below. This is the table. With the values of P given to 4 significant figures, where appropriate. Use the given equation, we are talking about this equation, to complete the table giving the values of P to 4 significant figures where appropriate. So basically we are asking us to fill up these empty boxes using this equation and to write how much power we get at that particular given time. So basically we have to substitute the values of P in this equation and get the value of power. Alright, for the first one where time is 10 hours, we have to take P is equal to 0.95 plus 2 raised to the power of 10 minus 12. So wherever you see the P, replace it with 10 plus 2 to the power of 12 minus 10 minus 10 minus 12 to the power of 2. This is at P equal to 10. So let us put it in the calculator and check how much we get. So here we have 0.95 plus 2 is raised to a power of, let me put a bracket here, 10 minus 12, close the bracket, and then plus 8 to 50 raised to the power, again put a bracket, and 12 minus 10, close the bracket, minus 10 minus 12, raise it to the power of 2. So let us see how much we get. We get it as 645. Or if you want to put it in decimals, we will get it as 1.2. So at T equal to 10, we get power as 1.2. So we write it as W. So we get it as 1.2 over 4. Similarly, we have to do for time 11.5. We over here. So we have to put it in the given expression as P equals 0.95 plus 2 raised to the power of 11.5 minus 12 plus 2 to the power of 11.5. So 2 to the power of 12 minus 11.5 minus 11.5 minus 12 whole square. So let us check it on the calculator how much we get. So we put it as 0.95 plus 2 raised to the power of the bracket 11.5 minus 12, close the bracket, plus 2 raised to the power of 12 minus 11.5, close the bracket, minus 11.5 minus 12 whole square. So let us see how much we get there. We get it as 2.821. So we take it as 2.821 kilowatts. Remember, they have asked us to write 4 significant figures. So we have to take 4 significant figures over here. So we write it here as 2.821. Let us now continue with the B part of the question 7. The amount of energy in kilowatts hour produced between 10 and 12 can be found by calculating the area of region R. So they are saying that the amount of energy in kilowatts hour produced between 10 and 12, we are talking about these times, between 10 and 12, can be found by calculating the area of region R. So this entire area between 10 and 12, we are talking about this. Use the trapezium rule with all the values of P in the completed table. We are talking about the table we just did above this table. So we have to make use of this table here to find the estimate for the amount of energy produced between 10 and 12. Give your answer to 2 decimal places. So here, first of all, we have to make use of this given curve, the area under the curve between 10 and 12 time, and then we have to use the trapezium rule to find out the area. So now we will use the previous table which we have written over here. So taking it down, so we have got the table over here. It's the exact same one as we have got above with the values of time and power P. So here at time P equal to 10, we have got the power as 1.2. So here we have the y-axis power as 1.2. At 10.5, okay, I have taken a neat image of the graph. So what it means, at time 10, we have the power given as 1.2. At 10, we have 1.2 over here. So let us write here 1.2 kilowatts. And similarly at 10.5, so somewhere between 10 and 11, we have 10.5, and that is equivalent to a power of 1.882. Similarly, we have at 11, we have a value of 2.45 over here. Similarly, at 11.5, it comes between 11 and 12. 11.5 is here. So we will be having a power of 2.821. And at 12, we have a power of 2.95. So here we have, let us just write it on the y-axis. This is 2.95. And the lower one is 2.821. And this is 2.45. And so on. You do not have to show it on the given figure 1. This is done only for your understanding. So this is how we are going to mark the power on the y-axis. This is your y-axis and this is your x-axis. This one. Now we have to use the trapezium rule with all the values of P in the completed table. So they have asked us to use the table to find out the area R by using trapezium rule. So let us write down the trapezium rule over here. Okay, this is the trapezium rule. I have written here area of trapezium is given as half times h multiplied with y0 plus 2 multiplied with y1 plus y2 and so on, plus yn. Now here we'll see what is h. H is nothing but the difference between these values. So here you can see between 10 and 11 there is 10.5. So h is nothing but the difference between the two consecutive times. So it is 10.5 minus 10. That gives you 0.5. If you see for between 11 and 10.5 also, if you take the difference between 11 and 10.5, that also gives you 0.5. Take the difference between 11.5 and 11, that also gives you 0.5. And the difference between 12 and 11.5 is also 0.5. So we can see that the h, the height or the difference between the consecutive time is 0.5 everywhere. Hence we have got h is equal to 0.5. Now next is what is y0. Y0 is the first value in the table which you get. That is this value at time equal to 10. So this becomes your y0. Then y1, y2 and so on. So we have to go just above. This is your y1, y2. And then you have above one y3. And then y4. So here y1, y2, y3 should be taken. Yn is nothing but the highest point which you have marked over here. This is nothing but your yn. Yn equal to y4. So substituting over here, we can write it as area of trapezium is 1 over 2 multiplied with height 0.5 in the bracket y0. We have seen it is the first y value, which is 1.2 plus 2 times, take the intermediate values y1, y2 and y3. So it becomes 1.882 plus 2.45, next value, plus the other value, plus 2.821, close the bracket, plus yn. Yn is the final y value in your figure 1, which is 2.95. 2.95. So let us calculate this using the calculator. Okay, so let us calculate now. So I will take the bracket values first. So I will be taking it as 1.2 plus 2 multiplied with 1.882 plus 2.45 plus 2.821, close the bracket, plus 2.95. So let us see how much we get. Okay, now this entire answer I am going to multiply with 0.5, multiply with 0.5, then I am going to divide it by 2. So divide it now. Let us see decimals how much we get. 4.614. So we write it as 4.614. So this is what we get the area of the trapezium as. And they want us to 2 decimal places. So here you can just write it as 4.61. 2 decimal places means 20. This is the answer we get, and the answer, the amount of energy is in kilowatts hour. So 4.64 kilowatts hour. This gives you the amount of energy produced. This is the answer for part B of the 7th question.